chapter. We're finally getting into calculus. The first chapter was just a review. Now we're going to finally get into calculus. So we're going to learn what a limit is today in 2.1. I think before I start, I just want to talk about something I already talked about in chapter 1. But in algebra, you had y equals x plus 1. And when you made your chart, when x is 1, y is 2, when x is 2, and y is 3. And the way we labeled our ordered pair was 1, 2. So that is algebra. And now, what does it look like more in calculus form? Instead of y, they use f of x equals x plus 1. The chart is x and f of x. You can still put a 1 in there and get a 2. You can put a 2 in there and get a 3. They don't write an ordered pair in calculus. Instead, they say f of 1 equals 2. See the difference between algebra and calculus? It's very important that you understand how it's worded. Before we move on, I can start, I guess. To find the average of something, you add the numbers up and divide by how many numbers. When I talk about instantaneous rate, I don't know why there's a space right there, but when I talk about instantaneous rate, you do it without delay. You do it without delay. Basically, that is what we're going to be getting into, is instantaneous rate. So for example, a rock falls off a cliff at f of t is equal to 16t squared. That's just the equation, which would be a parabola, correct? Because it's to the second power. You're supposed to find the average speed after the first 2 seconds. What's the average speed? I'm just going to circle because you have to start looking at keywords. Whenever you see average speed, it says to find the slope. Another name for speed, they could say find the average rate. On the AP test, if it says to find the average speed or the average rate, they're asking you to find the slope. So what I'm going to do is go over here, and I'm gonna, my f of t is really y equals 16t squared. So my y is really f of t. And what I'm going to do is I'm going to make a t and an f of t chart. And I want to find the rate, the average slope or average rate after the first 2 seconds. So if my time is 0, my y value is also going to be 0 because I put t in place of 0 into the equation, I get 0. When I put 2 in there, 2 squared is 4, and 4 times 16 is 64. So what I'm going to do is find my slope. These are my x's and these are my y's, and it's y minus y over x minus x. So I'm just going to do it over here. 64 minus 0 over 2 minus 0 is equal to 32 meters per second. You're going to be asked to find the average speed and the average rate a lot throughout this year. So remember those keywords. Now, we're going to find the instantaneous rate at t equals 2. You're going to get more exposed to the instantaneous rate, not until 2.4. Right now, I'm just going to expose you to this. Just to give you an idea. So instantaneous rate at t is equal to 2 means what's it going to be later on after 2? So we already know that at f of 2, the y value is 64. Remember, I could write this as an ordered pair of 2, 64. And then what is it later? F of 2 plus h. That's later. So if I look at, if this is 0 and this is 2, This is farther along, which is 2 plus h. It could be 2 plus 1, it could be 2 plus 2, or 2 plus 3. So it could be a 3, a 4, or 5. We don't know what that is, so we just call it f of 2 plus h. And basically, how do you get the answer to f of 2 plus h? I want to go back up and look at this again, you guys. The equation, remember, is f of t is equal to 16t squared. How did I get 64? In place of t, I put 2. So how do I get 2 plus h? So all I'm going to do is, in place of all of the t's, I'm going to put, 2 plus h. So it's going to look like 16, but in place of the t, I put a 2 in there to get 64, but now I'm going to have to put a 2 plus h in there, and I square it, which is equal to 16, and I know that that's made up of 2 plus h twice, which is equal to 16, and when I do the FOIL method, I'm going to get 4 plus 2h plus 2h is 4h plus h squared, which will give me, if I do the distributive property, 64 plus 64h plus 16h squared. Okay, and now what we're going to do is do exactly the same thing. We're going to find the slope. But this is different because it's easy to find the slope up here, you guys. It was easy to find the slope up here when you were given 2 x values and 2 y values. It was easy to find the slope because I did y minus y over x minus x. This chapter, it's not going to be as easy to find the slope. I'm just going to show you. You had a t and an f of t. I'm just going to show you the number line now, or the table. When you tried a 2, it was supposed to be 64. But now the next, it's not going to say a number, it's going to say 2 plus h. So in place of all the t's, I put 2 plus h. So I got 64 plus 64 h's plus 16h squared for my y value. And now I'm going to do the same thing. To find the slope, I need to do y minus y over x minus x. And these are my y values. So I'm going to do the second y, which is all of this, minus the 64 divided by 2 plus h minus 2. And you're going to get the 64's cancel each other out and the 2's cancel each other out. You're going to be left with 64h plus 16h squared all over h, which is just, instead of numerical, you have some variables in the slope with this. Okay, what is this leading up to? This is leading up to finding the limit. So what is the definition of a limit? The limit as x is approaching c of some function has to equal some L value. So here's a picture of it. As x is approaching some c, so we have some x value here, and we have another x plus h value down here. As x is approaching c, you are going to find some L value, which is really the y-axis, and some lambda minus the epsilon, and some L minus the epsilon. So you have a curve that looks something like this. As you are approaching this spot from the right and from the left, some c value, there is going to be some y value. And that is what a limit is. There are 3 ways to find a limit. You can look at the graph. So you can look at a graph to find the limit. You can look at a table to find the limit. So x, f of x. Or you can solve it analytically you can solve it using an equation. I don't know if you have your book handy, but if you look at your book and you look at the title of the book, it says calculus. And if you read underneath calculus, it says you can solve calculus graphically, numerically, and algebraically. That is solving. So that's that last one, algebraically. We're going to be able to solve it graphically, numerically using a table, and analytically, algebraically. So we are going to figure out how to find the limit. And basically, I want to go back to the last page really quickly here. We figured out here, keeps missing, this is the slope. To find the limit, you need to do the limit as h approaches 0 of 64h plus 16h squared all over h. This is the slope formula, and now we're leading into limits. There's a limit as h approaches 0 in front of this part, in front of the slope, and that's what makes it a limit. But again, we're going to dabble in this farther along in another chapter. So I think the first way we're going to solve is graphically. So let's find limits graphically. So we're here, and I need you to memorize this one. What is the limit as x approaches 0 of the sine of x over x? And right now we're going to just dabble in graphically because I think visually you can see how to find the limit. So let's look at it graphically. So I want everybody to put the sine of x over x into your calculator. The sine of x over x into your calculator. Everybody sees the y equals button in the gray area, and the window, and the zoom, and so on. You need to go under y equals, and up above y equals, you need to type that in. Make sure your calculator's in radians when you type that in. So just go into your mode really quickly and look to see if your calculator's in radians. So I'm going to go under y equals, and I'm going to use my alpha y equals, so I can use my n divided by d button, and I'm going to put the sine of x divided by x into my calculator. And I'm going to graph it. And this is what it's going to look like when you graph it. This is 1, this is 2, and it looks like something like that when you graph it. Okay, so let's find the limit. Let's find the limit as x is approaching 0. Okay, what does that mean? What is the limit as x is approaching 0? So this is what I like doing. You have to approach 0 from the right side of it and from the left side of 0. Here's x equals 0 right here, you guys. And you could put like a little car on here, and you're going towards 0 from the right, and you're going towards 0 from the left. What's the intended y value? What's the y value going to equal? The y value is going to equal 1. You also have to know these. What is the limit as x approaches 0 of the sine of 2x over 2x? That's also equal to 1. And the limit as x approaches 0 of the sine of 3x over 3x is also equal to 1. So all of those are equal to 1. Okay, we're going to do another graphic one. So here's some more graphics to learn how to find the limit graphically, and then we'll dabble in how to find the limit using a table and solving it algebraically. So let's just draw some graphs so that we can study different types of graphs. Let's put an open circle here and make the line like that. Let's make 2 dashes and another dash. Let's put a closed circle here though and an open circle here. And let's make another one. Let's just make it completely just a line. We have 3 different types of graph. And what we are going to do is we're going to find the limit as x is approaching 1 of this f of x. We're going to find the limit as x approaches 1 for g of x. And we're going to find the limit as x approaches 1 of h of x. So let's look at it graphically. Okay, when you're approaching 1, here's x equals 1 right here. That's all I'm looking at. I'm only looking at x equals 1. And as you're approaching it, here's like a car, and you're coming towards it from the right. And you're approaching it, I like using a car, from the left. And as you're approaching it, what is the y value intended to be? The y value is intended to be a 2. Even though it's open circle, it's the intended y value. So let's go back to this page. L stands for the intended y value. The intended y value. It doesn't have to be there as long as you're getting closer and closer to it. What's the limit as you're approaching 1 from the right, approaching 1 from the left? It's very similar to the last one. This is also has a intended y value of 2. And you're approaching it from the right and you're approaching it from the left. It is, the y value is equal to 2. Okay, now, I just told you what a limit was. It can have an open circle there or it can be a closed circle there, correct? As long as there's a road going to the y value, as long as there's a road, like the car is on the road, as long as there's a road going to the y value, there is a limit, you guys. This right here is something different. I want to talk about that. That's not the limit. That is, what is g of 1? What is the y value when g of 1? That's equal to 1. That's the actual y value. This is a point. This is what we've been learning all the way up until calculus. This is a limit. A limit has to have a road going to it from both sides. Okay, here are some rules. A limit as x approaches c of some k value equals k. So the limit as x approaches some c value when this is equal to x is going to equal to the c value. So I'd rather just do this. Let's do this instead. The limit as x approaches 2 of 4 needs to equal 4. How's that? And so I'll just show you graphically so that you understand. This is the f of x function, and the f of x function is y equals 4. If y is equal to 4, it's a horizontal line at 4. So this is at 4. As x is approaching 2, here's 2. What's the intended y value? The intended y value is 4. If you have 2 different functions, f of x and g of x, you can split them up. You could do the limit of f of x as x approaches c plus the limit of g of x as x approaches c. So you can split it up, plus or minus. Okay, the next limit formula is a one-sided and a two-sided limit. So I'm going to talk about this right here, down here. So a one-sided limit can occur. So if you see a little plus above your, as x is approaching 3 or as x is approaching 2, and there's a little plus there, that means you're only approaching it from the right side. You're approaching that x value from the right side. If you see as x is approaching c with a negative, you're only approaching it from the left side. But if you don't see a plus or a minus and you just see a c, you're approaching that x value from both sides. And here's the most important rule for a limit. If you're approaching the x from the right, which is a plus, and you get an L, and you're approaching it from the left, and you also have an L, then the limit of f of x has to equal L from both sides. So I'll do some more examples for you. And here comes the next one. Okay, let's look at it. Let's look at another graphic. Again, we're only finding limits graphically right now. We haven't learned how to do the other way yet. We're just trying to figure out how to find a limit graphically. You might have to turn this off. I don't know if I have the graph given to you. I don't know if I have all that stuff down below given to you. So you might have to shut it off and write this all down. Okay, we're back. You should have this all copied down. Okay, so we are going to find the limit graphically now. So we haven't, let's start with the first one. We're going to find the limit graphically. And here's the graph up above. So here we go. This is some function x. So what's the limit? So here's f of x. That just tells you we're looking up above to that function. And we're approaching 1. X is approaching 1. Do you remember what the negative sign stands for? We're approaching 1 from the left side of 1. Well, here's 1, you guys. That's x is equal to 1. And we're approaching it from the left side. Well, isn't this the left side of 1 right here? Isn't this the left side? So if I took a car and I approached that open circle from the left and I have that car coming towards that 0, isn't the intended y value 0? Okay, let's approach 1 from the right. If we're going to approach 1 from the right, there has to be a road coming from the right side of 1. Well, here's 1. This is x equals 1. Here's the road, and it's approaching it from the right. The intended y value is 1. Okay, now find the limit of f of x as x is approaching 1. There is no plus, there is no minus. What happens if it's approaching just 1? If it's approaching 1, it's coming from both sides. And let's go back to the rule. If it's approaching 1 from the right, I got, what did I get? From the right, I got I think I got a 1 there. Approaching it from the left, I got a 0 here. Since these two numbers are not the same, the 1 and the 0 are not the same, then you cannot have a limit right there. So I'm going to go back, and I don't know if any of you guys have seen the movie Mean Girls, and she's at that math league, and they have to answer the question, and she says the limit does not exist. The limit does not exist. That's what DNE stands for. Does not exist. The limit does not exist. The reason why the limit does not exist is because this number and this number are not the same number. Okay, let's do the limit as x approaches 2 from the left and the limit of f of x as x approaches 2 from the right. Let's figure out what these two answers are. And then we're going to come down here. I don't know why that wasn't underneath it, and do that one. Okay, so here we go. The limit as x is approaching 2 from the left. Where is x equals 2? Here's x equals 2. and we're approaching it from the left side of that open circle. Everybody see a road going to 2? It's going to equal 1 as you're approaching 2 from the left side. And now you're approaching 2 from the right side, so you're going to put a little car on the right side to the right of x equals 2 and have it come towards x equals 2. That's also equal to 1. Since these numbers are exactly the same, then the limit as x approaches 2 is also 1 from both sides. Okay, let's do some other ones. Let's find the limit. Let's find the limit of f of x as x is approaching 0 from the left. This is 0 from the left. So where's x equals 0? Here's x equals 0, and you're approaching it from the left side. Isn't this the left side of 0? Do you notice that there's no road or a line or a path going towards it? This one does not exist. Okay, let's do 3 from the left. Where's 3? Right here is x equals 3 from the left. You're approaching 3 from the left side of it. Well, here's the y value, and you're approaching it from the left side. Can you approach it? Is there a road coming towards the 3 from the left side? Yes, and the answer is 2. What about 4 from the left side? What's the limit as x is approaching 4 from the left? Is there a road coming from the left side? Yes, and it's equal to 1. And that's how you do limits. There has to be a road going towards it. Now, let's go back to algebra. Algebra, they're not asking you what the limit is. In algebra, they're asking you, what is f of 1? What is the point of f of 1? F of 1 has to be a closed circle. F of 1, which is right here, you guys, f of 1 is equal to 1 because it's the closed dot. It's the ordered pair of 1, 1. What's f of 2? F of 2 is also equal to 2. So limits are more calculus, and the dots are, you can have like this one, the dot, f of 1 equals 1, the point, and the limit could be the same. See that? Okay, the next part. You do not need to know the sandwich theorem, but I'll just talk about the sandwich theorem. If you have one graph that looks like this, and you have another graph that looks like this, as you're coming towards this x value, it gets sandwiched in between it, and it'll give you your y value. It's called the sandwich theorem, but they don't really test you much on the sandwich theorem. Okay, I want to go back, and I want to go back to teach you that we just learned it graphically. One more. We just learned how to find the limit graphically. I'm going to show you how to do it numerically, and I'm going to show you how to find it analytically, algebraically. So here are the other ways to solve them. Okay, next page. Solve using substitution or analytically, or let's call it algebraically instead. We are going to verify it using a table and a graph. I'm just going to show you that you can do it 3 different ways. So the first way is algebraically. What is the limit as x approaches 1? And this is your f of x, 3x minus 4. To do it algebraically, all I do is substitute in place of x1. 3 take away 4 is equal to the limit as x approaches 1 of 3x minus 4 is equal to a negative 1. All I did was substitute in place of x a negative 1. Okay, the second way I'm going to show you is graphically. So everybody take your calculators out. I want you to go under y equals. And under y equals, I want you to type in 3x minus 4. And I want you to hit the graph. and it looks like this. That's what it looks like. So as you're approaching 1, here's about the 1 marker. What's your intended y value? Is there a road going to x equals 1 from both sides? Yes, and it looks like a -1. So I showed you graphically. And now I'm going to show you using a table. So way over to the right, you see a table, which is in blue, so you have to do second table. So go under second table. Let me get my calculator out one more time here. Go under second, so I'm going to plug in 3x minus 4. I'll wait for you guys to do it too. And go to second graph, and you'll see a table, okay? And you're going to get better at using your table, but we went under the table. And something new that maybe you've never done before, I want you to do second table set, which is second window. And I want to start my table specifically at x equals 1. And I want my change in my table. Let's count by 0.01. I want to count by 0.01 on my table. So instead of counting by ones, I'm going to count by 0.01. So go to your table, and it should start at 1 if you start your table set at 1. And I'm just going to arrow up a little bit. And this is what my table looks like. If you counted by 0.01 and you started at 1, I'm just going to show you what my table looks like. I'm just going to arrow up a little bit. So you have a 1 and a -1. And then at 0.99, it's a -1.03. And at 0.98, it's a -1.09. And then at 1.01, it's at negative, it's at negative 0.97, and I think you get the idea. 1.102, it's at -0.94. Just to show you, as you're getting close to 1, here's the 1 marker. The answer is a -1, it even tells you. But on either side of it, do you see that these numbers are getting closer? As you get closer to this number from the left and to the right, you're getting closer and closer and closer to a -1. So that's how you use your table. You don't have to count by 0.01. If you even want to be more accurate, you could count by 0.001 if you want to see what it's getting closer and closer and closer to. So I showed you using algebra, I showed you using a graph, and now I just showed you how to use it doing a table. Okay, the next one. When you plug a -2 in here, you're gonna get undefined, because you can never have 0 in the denominator in math. So I'm going to show you 3 different ways. The first way is the limit as x approaches a -2, and I'm going to use my factoring skills from algebra. Factors of 6 are x plus 3 and x plus 2, and divide it by x plus 2. I'm going to cancel out the x plus 2's. Do you see how I canceled out the x plus 2's? Now that I canceled out the x plus 2, I can algebraically solve for it, and when I plug a -2 up into x plus 3, my limit's going to equal 1. When I look at it graphically, I can plug this into my calculator. My limit's also going to be 1. And then if I look at my table, specifically at x is equal to a -2, it's also equal to 1. If I were you, I would just play around with this. I would plug in x plus 3 really quickly. I would look at the graph, and your y value should be 1 when you look at the graph, which it does. And then what I would do is look at your table, and you would need to change your table set. You need to start at a -2 and count by 0.01. and look at your table, and at -2, as you get closer and closer to a -2, the answer is 1. Okay, the next one, last one, I'm going to do it, I'm going to do this one. I'm going to show you all the ways. I'm going to show you algebraically first of all. Algebraically, you need to use trigonometry. This is where trig comes into play. So you're going to do the limit as x approaches 0, and tangent from trig is the sine of x over the cosine of x, all over x. You should remember that. They're expecting you to do this problem without a calculator. So you can't really graph this one. And then this is going to be the sine of x over the cosine of x. Change the division sign to multiplication and flip it. You're going to get the limit as x approaches 0 of the sine of x over x times 1 over the cosine of x. I told you in a couple of screens ago to memorize that one. You can break this up. The limit as x approaches 0 of the sine of x over x, I told you was 1. And you need to figure out what is the cosine at 0. The cosine at 0, if you guys remember trig, the cosine at 0 is 1. So you have 1 times 1, which is equal to 1. So that's how you do it algebraically. How to do it graphically, all you do is you just plug it into your calculator, and this is what it looks like graphically. You have a graph that looks like this, then you have a parabola that looks like this, and then you have another graph that looks like this. And as x is approaching 0, right here, from the left and right, you can see that it's also equal to 1. And then you can look, since your graph is given, you can go under your table and look to see also. Okay, I know these are long notes, but is this the last page? Nope, we have a lot more pages. So this has to be broken up into a couple of days. So you'll be watching this video for a couple of days. But again, I'm just going to go over this again. It doesn't hurt. I'm going to make another graph. And I'm just going to put a little closed circle with a little loop to here with another closed circle. I'm going to have an open circle to there. And then I'm going to put a closed circle with an open circle with a closed circle like this. And then above that, I'm going to put a closed circle. And I'm just going to play around with this and see how good you are at doing it graphically. I might do a couple more. Okay, I'm just going to do a couple more even. So you can turn this off, make these notes, and turn them back on. Okay, we're back. Let's keep practicing graphically. The table just gives you the answer pretty much by changing your table set. The substitution, you might have to factor, like I did in that one problem. But let's keep doing a little bit more of this. What's the limit as x is approaching 2? Where's the number 2? Here's x equals 2 right here. And you're approaching it from the left side. So look at number 2, approaching it from the left side of that. Is there a road going towards it? Yes, there is. And the y value is 1. What's the limit as x is approaching? I'm going to do this one down here. As it's approaching 2 from the right side. It's approaching 2 from the right side is also 1. Remember, it's the intended value. It does not have to be there. What's the limit as x is approaching a -1, you guys? Here's a -1 right here. You're approaching x from a -1. Notice that there's no plus or minus above it. If there's no plus or minus, that means the road has to come from both sides. And there's only a road coming from the right side, so the limit does not exist. The limit of x to the -1 from the left side, let's make this positive instead. What's the limit as x is approaching a -1 from the right side? You're approaching it from this side, it's equal to 1. What's the limit of f of x as x is approaching a positive 1? Well, here's the positive 1 from the right side. From the right side, it's equal to 1. No more limits. We're going back to algebra. What is the point f of 2? The point at f of 2. Well, the point f of 2 is equal to 2. Just to give you a little bit of what's algebra now. Okay, last page, I think. Let's look. Yes, we are on the last page. The first thing they want you to do is draw a graph, and then they want you to find the limit when x approaches a -1 from the right, and they want you to find as x approaches a -1 from the left, and does the limit exist? So here we go. You know that this is supposed to be not equal to a -1. So you know that that's a parabola because it's a x squared. It's an upside down parabola because it's a negative, and it got shifted up 1, so it looks like this. You can graph it if you want, 1 minus x squared on your calculator, but x cannot equal a -1. So if x does not equal a -1, at the -1 marker, I'm going to put an open circle right there because it does not equal a -1. And y equals 2 when x equals a -1. Well, here's a -1. That means the y value equals 2. So there's a dot there instead. So that's what my graph looks like. And you have to be pretty good at drawing a graph. And now we're going to look at the graph and find the limit as x is approaching a -1. Well, here's the -1 from the right side and from the left side. I'm going to get an answer for this one of 0, and I'm also getting an answer of this one is 0. Does the limit exist? Does the limit exist at a -1? Yes, because both answers is 0. Okay, we'll do another one, and I think we are done. So this is supposed to be the square root of 1 minus x squared. So you can graph the square root of 1 minus x squared from 0 to 1. And how do you plug this into your calculator? You do y1 equals, you would put the parentheses, the square root of 1 minus x squared. And then after that, you would say x. And then under math, not under math, right above math, it says a test. Everybody see test right above math? You have to use parentheses. So you do a parenthesis, the square root of 1 minus x squared, parenthesis, x is greater than or equal to 0. And then another parenthesis, x is less than 1. So that's how you get those inequality signs, is going under test. It's right above math. And then under y2, you can put 1, and you really don't have to, because this is just going to be a point. The point is going to be from 1 to 2, and then you're going to have a point. So this is what your graph's going to look like. It's going to be a half of a circle, a quarter of a circle, sorry. And you're going to have a closed circle here and an open circle here. And then the next one is, this is 1, and this is 2. This is 1 and 2. Y is equal to 1 from 1 to 2, but this is a closed circle here, but an open circle here. And then x equals 2 here. So this is what the graph looks like. If you just have, this one just makes a point because x equals 2, where this one's going to make a line because you have more of a longer domain. So this is what the graph looks like. And then they're just going to ask you, what is the point C? Does only the left hand, where you're looking at C is equal to 1. So you're looking at C is equal to 1. At what point C does only the left hand limit exist? At what point C does only the left hand limit exist? Or all the C values, not just C equals 1. We also have a C equals 2, because we have 2 values. Oh, we also have it 0, 2, sorry. X equals 0, x equals 1, and x equals 2. These are our C values. At what point C does only the left-hand limit exist? Only the left-hand limit exists. Well, at x equals 0, the left-hand limit does not exist. At x equals 1, the left-hand limit exists. And at what point C does only the left-hand limit exist? Well, if you're talking only, we can't do this one because the right-hand limit exists at 1 also. The only spot where only the left-hand limit exists is x equals 2. It's right here. This is the only, it only has a one-sided limit and it's a left-hand. At what point C does only the right-hand limit exist? At x equals 0. At what point x does both limits exist from the left and to the right? That would be x equals 1. Both limits exist. That would be x equals 1. That is it for your notes on limits.